All right. Law of Sines, Chapter 6, point 1. So, before I gave you the formula for law of sines, I thought I'd show you kind of a makeshift proof of how we come up with law of sines, so you don't think I'm just making this stuff up. So, here I have a triangle. All my sides are lowercase c, lowercase b, lowercase A, capital C, capital B. I'm not going to define and prove the whole law of sines, but I just enough to give you an idea of where this is coming from. So as you are aware, if I asked you, well, first let's make sure you know this is a right triangle, or at least the line coming forming H is making it right. And if I said, what's sine of B equal to, what would it be? You know that sine of B in a right triangle is opposite over hypotenuse. Opposite of capital B is H. H over the hypotenuse, which is A in this case. So it'd be H over A. So, and then if I asked you about sine of capital A, opposite would be H over its hypotenuse, which is lowercase b. If I isolate H in both of those, multiply A to the other side, I get A sine capital B, and then B sine capital A equals H. Since H is going to be equal to both these things, right? A sine B and B sine A. So A sine B equals B sine A. I'm just going to get rid of, divide both sides by AB. That's going to get me sine of B over lowercase b equals sine of A over lowercase a, giving us what law of sines basically is. What law of sines tells us about the three sides, and it's also C. I could do C to this side, but for the sake of time, and I don't want you to have to hear me go through proving C as well, because I don't want to take up all your time. That's an ugly C. I will fix that. We'll take up time doing that, though. Sine of capital C equals lowercase c equals sine of B over lowercase b equals sine of capital A over lowercase a. That is the formula we'll be using for all these problems. Make quick note, so your book did flip these. They put lowercase c over sine capital C and lowercase b over sine capital B. If you want to write it that way, that's fine. You do you, however you want to write it, as long as all the signs are either on the numerator or all the signs are either on the denominator and you're consistent with that. Alright, so an AAS triangle example. So I'm giving you capital A is equal to 30 degrees, capital B is equal to 45 degrees, and lowercase a is equal to 32. And we need to find the rest of the information. So, the one easy bit of information we should find right away is C. Capital C, that is, because you know that a triangle equals 180 degrees. So we get 180 minus 30 minus 45. That'll get us 105 degrees. And then from there, we have to use law of sines in order to solve. What I normally like to do is I always use what's given to us. So sine 30 over 32 equals sine 45 over lowercase b. And then we have to cross multiply. So b sine 30 equals 32 sine 45. Divide both sides by sine 30. And then when you put this in your calculator, make sure put parentheses around the 32 sine 45 in case the calculator does not, just for the sake of order of operations, because you should do that first before you divide by sine 30. And that will get us b is equal to 45.25. So we know that as well, and we need lowercase c still. I'm going to still use capital A and lowercase a because that's the most exact answer. We should roll with that. And then we get sine 30 over 32 equals sine 105 over lowercase c. Cross multiply, you get c sine 30 equals 32 sine 105 divided by sine 30. And that will get us C is equal to 61.82. I rounded to 2 decimal places in these cases. All right. And here we have an angle side angle example, which is similar because since we have a missing angle, it's an easy one to find. Take 180 and subtract these two, and we're going to get 120 degrees. So that's one unknown we found, and we need to find the other two. We're given the C's, so sine of 120 over 20 equals sine of 15 over lowercase b. Cross multiply, and then divide by sine of 120, and you will get, B is equal to 5.98. And then for the other one, same story, except we're using 45. Sine of 45 over lowercase a is equal to sine of 120 over 20. Cross multiply, get 20 sine 45 equals a sine 120. Divide by sine 120. And you will get A is equal to 16.33. And those are solutions. And now for SSA examples. As you notice in the guided notes that there is 3 different examples because there's 3 different things that could possibly happen. Here's the basic one. And for those of you that forget what SSA and all the other ones mean, if I'm giving you 31 degrees there, 12, and let's say B, we'll call this B is 5. We'll make it the other side here. So it's, well, that's still side, never mind. So side, angle. So side, angle, because it goes in the order side, then angle. In this case, I'm going to tell you right now we're going to get one solution. That's going to be relevant later in this video. I'll explain how we know whether it's one solution, no solution, or 2 solutions later on. So we have sine of 31 over 12 equals sine of b equals 5. Or it's not equals 5, it's over 5. Then you cross multiply, get 5 sine of 31 equals 12 sine b. Divide by 12, and you will get about 0.15 equals sine b. So you're going to go in your calculator, do second sine of both sides. Make sure your calculator is in degree mode for this because we're working in degrees. So inverse sine of that value. Try to keep it as the same numbers before. I'm just rounding for here. And that will get you B is equal to 12 point, I'm going to do 2 decimal places, 40, or 39 rather. 39 would be rounding. 12.39 degrees. So in order to find C, we're going to need to do, first off, just simply 180 minus those 2 degrees. And when you do 180 minus those 2 degrees, you'll get 136.61. And then we need to find lowercase c. So we get sine of 136.61 over lowercase c equals sine 31 over 12. Cross multiply. Divide by sine 31, and we'll get c is equal to sine 31. C is equal to 16.01. Okay, and that is for this one right here. Now here's an SSA example when there is no solutions. So let's begin by trying to solve this. We get sine of 60 over 4 equals sine capital B over 14. Cross multiply. And when we do that, we get sine of B is equal to 3.03, and when you do inverse sine, you get an error. When you see that, you know there is no triangles. Kind of a giveaway, but don't assume this every time. When you see that, if you think about this here, if A is equal to 6 degrees and its side opposite is 14, and you have another side that's 14 compared to 4, and you already used 6 degrees, then this degree must be really, really big, and it's going to be too big for a triangle. Okay, so clearly no triangle, not a triangle in this case. All right, so this is the SSA example where there's two solutions. I'm going to tell you how some of the things you should look for in order to tell that there are two solutions. Number one, so if I'm given, let's say this is angle A right here. I'm going to do a makeshift drawing. This is A, and this is my lowercase a, and that's my lowercase b. If I see that the side opposite of the angle given is smaller than the other side given, that's possibly a two triangle scenario. Okay, I'm not saying it is for sure, but that is a possibility. Now your book kind of explains it in a way that is kind of easier than what I've always been taught. So I'm gonna go with this. If you're interested in what I did, like in years past, when I haven't had this book in front of me, and when I didn't have my previous maths going through this, I have another way of checking this. If you want to find out what that is, I'd be more than happy to talk about it. But it is kind of dealing with the same thing, and that is, let's say we have our height, like I showed in the first slide. That's my height. Okay. So in order to find out what the height is, if I do similar to what we did before, we do B sine A is equal to H, as you saw in the first slide. That's 5 sine of 58, and we do 5 sine of 58. That gets you 4.24. Okay. Now, why is that relevant? If H is smaller than A, that's smaller than B. Now, A and B are the ones given to us. A is just representing the side opposite of the angle given, and B being the other side given. If H is smaller than both of those, and as I said before, the side opposite, I'm going to say this over and over again so it's in your head. The side opposite of the angle given is smaller than the other side given, and the H is smaller than all those, then you know it's a two triangle problem. Because what can happen is, since H is smaller than both those, that means, I'm going to use a different color marker here, that means not only can capital A be right there technically, it can also potentially be right here. So there's two different triangles it can potentially be because of the given dimensions and information given to you. So I'm going to do some different labeling here. Capital B prime right there, and then I'm just going to do regular old B over here. We solve for the regular triangle. And then we're going to have capital C right there is going to be that whole thing up top, and then capital C prime would be whatever that smaller angle is right there. And then we're going to have lowercase c prime there. That's going to be right there, and then lowercase c prime would be there, or that's not lowercase c prime, oops. Lowercase c, just lowercase c in general, not prime, because prime is that small one right there. Now I'm going to do everything that's not prime first, to try to make things a little easy to navigate. So I'm going to have that. I have lowercase c, I have capital C, and then I'm going to have, I don't have lowercase b prime because I already was given that, but I do have capital B prime, and then I'm going to have capital C prime and lowercase c prime. So, a lot of work to do, as I said, so let's do it. Sine of capital B over 5 equals sine of 58 over 4.5. For the sake of space and time, I'm going to trust that you can cross multiply and figure that one out, and that answer will be approximately 70.40. Or just do 70.4. We're rounding to one decimal place now. So next, we can find capital C real easily because 180 minus those values will get you 51.6 degrees. And then lowercase c, because I don't want that, 51.6 over, we don't know the opposite side, and then that equals sine of 58 over 4.5, get us lowercase c of 4.16 feet. Now to find all the primes. So I'll set that up in red, and sine of b prime over 5 equals sine of 58 over 4.5. Cross multiply, I'm going to get b prime is equal to 109.6. Meaning that c prime, if we add them up and take leftovers, that's just going to be 12.4 degrees. And then from there, we have to use law of sines again, which is sine of 12.4. Always use what's given. That's the sine of 58 over 4.5. And we don't know what c prime is. And then c prime, lowercase c prime, will get you 1.14 feet. Whew. Okay, that's that one right there. And finally, finding the area of an oblique triangle is just simply this formula. 1/2 BC sine capital A. It's anytime you're given two sides and an angle, and that angle is not opposite any of those sides. So it can also be 1/2 AC sine capital B and 1/2. No, I did not do that one. BA or AB sine of capital C. So any of those three could be a formula depending on what you're given. So let's say I'm giving you an 80-degree angle. Let's just give it a capital C, and then lowercase c and lowercase b in this case are 24 and 18. So we need to find the area of that. 1/2 times 24 times 18 times sine of 80, and that will get us 212.72. And then units, whatever the units are. And since this is area, we'll call it units squared. Okay. Thank you for watching, and have a wonderful day.